Hello, I'm Pam Hoffman, Everyday Spacer.
I'm Jeff Miller, 2049 Outfitters.
At Everyday Spacer, we show regular folks how to personally and directly participate in space exploration, science, and astronomy. We're here on Friday nights at 9 p.m. Pacific Time, 12 midnight Eastern Time, and 2 p.m. on Saturday in Queensland, Australia. We're broadcasting live from Thousand Oaks, California. Thank you so much for joining us. Tonight's topic is cosmic Muon images. We'll be back in 8.3 seconds. Sadly, our scheduled guest, Miss Covey Denton, got sick, so we will hear from her another time. We switched to a citizen science project from Zooniverse, called Cosmic Muon Images. From the Zooniverse website, to paraphrase, try to find the proper particle tracks and extra particle strikes on the detector surfaces. The introductory workflow looks at simpler cases. The FreeStyle workflow looks at events where the proposition of a track becomes difficult for our machine, but it should be easy if you spent some time in the introductory workflow. Thanks to Jeff for scrambling to have a new show for us tonight. Over to you, Jeff.
Okay, well, in scrambling for this show, I poached something off of Zooniverse.
Okay.
I just had to say that. Standard Zooniverse interface, about classified talk, cosmic muon images. They have a poll, which if you're on the site, go for it. Reinforce has a youth art and science contest, but apparently that's done with.
Yeah, it said September 15th. That was yesterday. I did check it out. It's over because I would have added it to our list to tell people about.
But Reinforce does very good Zooniverse projects.
I agree.
So we've done a few of these before.
Yes.
Using muon tomography, we can probe the internal structure of massive objects like volcanoes with particles from stars and galaxies far away. You see, we're not actually doing something that's space-based, but the muons are from space. So, it's muons from space. And if we were a professional outfit, I'd have had an echo chamber effect on that.
I just want to say hello to Scott and Cliff. Thanks so much for joining us.
Hi, guys.
And we're very sad about Ms. Denton as well. You ready to go back?
Sure.
All righty.
Are you ready for me to go back?
No, not at all.
Because, muons from space are...
oh, boy.
are they're from space cows.
I'm not sure what you're trying to say, but I don't get it. Does anybody out there get it?
Oh,
Muon. They're muons, not muons. All right, now I'm with you. Who knew?
And actually, the muons themselves aren't from space.
Okay.
Cosmic rays come in and hit our atmosphere and break up into a bunch of things, including muons.
Okay.
So the muons are produced by the cascade of a cosmic ray hitting our atmosphere.
All right.
So they're not actually from space.
Okay.
And they're actually...
I thought you found them in like a particle accelerator, actually.
Well, you do, but you also find them because, cosmic rays are essentially a particle accelerator.
Okay.
They're hitting our atmosphere and breaking up into various
when
things.
they hit other things.
Yeah.
All right, I get it. And this part he's got here, I actually was reading from that.
Yeah.
Scott says, I am fascinated by muons, so this sounds like my kind of project.
Yeah.
Yeah, go for it, Scott. I love particle physics myself too, very, very much. I'll read particle physics books just for fun.
Yeah.
What can I say?
And the project is actually deceptively simple, and I'll say deceptively because it seems simpler than it is.
Oh, okay.
And
it seems very simple. I didn't delve into it very much, but I did look it over a bit.
And definitely read the field guide.
Okay.
Because there's some nuance in the field guide that they did not give in the tutorial.
Oh, okay. See, this is why we do this. So you know to look at things like the field guide in this case.
Yeah. So here we go. This is what we're getting here. Basically, they're using, and this is just an example. We'll get it more into it when we go into the intro and
It's
about.
quite finished. I mean,
yeah.
But they've added some things before, so they may again, right?
Yeah.
Okay.
This is, they don't have a lot of subjects to classify, and they're pretty well through with them. But I would imagine that as they, hey, Daniel.
You want to read it?
Sure.
If you were an atomic nuclei hitting the atmosphere at 50% of light speed, you'd create a shower of secondary particles too.
Yep.
I think that's true. Yeah.
Yeah. And here's the thing, muons are very short-lived.
Okay.
However, they're traveling fast enough that the relativistic time slowdown for them is that they're actually experiencing time slower than us.
Okay.
So whereas like they don't normally only travel a few meters before decaying, since time is so slowed down for them, they're traveling a few kilometers before decaying. So that's why we can use them for this sort of thing.
And Daniel, thanks for joining us. Glad you're here.
Yeah. So let's go back here. And here we go. This is about the muon images.
This one wasn't exactly like the normal ones I've seen. It was kind of less informative, I thought.
Yeah.
I kind of wish they had done a little bit different intro for this.
There's a lot more in the about.
Oh, okay. All right.
There's a lot more in the about. And as I said, field guide gives you some nuances.
Cool.
So they use it for studying the structures of underground things like volcanoes and stuff like that.
Right.
And generally, but not underground. They have to be below what they're looking at.
Okay.
So they have to angle upward somewhat, or at least horizontal. Because they do not travel long enough to go through the Earth.
Okay.
Unlike
neutrinos, which do.
Right.
Neutrinos go through everything.
Right. Yeah.
They interact with very, very few things.
Yeah. Our neutrino detectors aren't good enough to actually do any kind of imaging with them.
Okay.
I mean, we possibly could if we sat there with a detector for like a decade or so.
Oh.
You know, you'd get enough hits to actually make something.
Yeah. Right. Yeah.
But our detectors don't catch enough of the neutrinos coming through. So they can use these to see some really good stuff. So
nice.
This is, and again, reinforced. And we've already done most of these. Deep Sea Explorers apparently uses muons also. So
neat.
Might cover that in the future.
Okay.
And now let's go to the about. And this is a long section, which, gives a lot of good info.
Yeah, I really love to, see the info, read the info, and learn from it, whether I participate in the project or not. So.
Yeah. So this is showing they've got 3 detectors, and they're aiming basically through this mountain here, down here.
Ah, okay.
And each detector gets, certain hits, and they're and we're not matching up detectors.
For the project. The project task is to...
Right. Our task is not that image. Our task is the detector. Basically marking what's an actual muon path so that they can weed out what they call the background. Anything that's not.
Yeah, noise is always a big,
noise.
Big deal to,
Yeah, so we're helping them work on their detectors, but we're not helping them image. Basically, if we can get the detectors tweaked up better, the images will be better.
Cool.
So that's...
Yeah, and again, computer brains versus human brains, we're better at patterns usually.
Exactly, and that's what they're saying is that because in the FAQ, one of the questions is, why not have the computers do it? Well, people are better at it.
Yeah, and it sounded like they tried. It sounded like they put us through that process already.
Yep. Well, in fact, one of the things that we're looking at, the first workflow, because there's 2 workflows here. The introductory workflow and the advanced one. The introductory workflow actually has computer generated paths.
Okay.
So there.
And I think it's to get used to it. And is it to verify as well, or just to get used to it?
That's to verify and to get used to it.
All right.
Although, quite frankly, and I didn't have a lot of time to play with it, but I did do like about 10 of the introductory ones.
Oh, cool.
And I didn't find any where the computer was wrong.
Ah, okay.
So
but they are simple, right? They consider them simple.
They're simple.
Yeah.
But like I said, they're deceptively simple because there's other things to look for in there. And there's a couple of juggly pieces to keep in mind. It's not difficult, but it's just some things to keep in mind.
Okay.
So this is basically describing what I just talked about over there. Introduction, like X-rays. Hey, look, you get very few X-rays where things absorb them. That's the thing with the muons. Too.
Okay. Yeah, that's actually the first picture of an X-ray. It was. Yeah. Did I say his name there?
Yeah, William Conrad.
His wife's hand.
Röntgen.
Yeah. I think they're German, right?
Yeah, and that's actually where we get the measurement for radiation. Was from him.
Mm-hmm.
Or we used to. Now they have a different scale.
Oh, okay.
But muon tomography, which is essentially taking X-rays with muons, are generated in a very similar manner.
Oh, I'm glad you said that. It's taking X-rays with muons. Okay.
Yeah.
Or taking muon rays.
Yeah. But, different muons have different energies. Apparently, there was one instance of the oh my God particle detected in 1991 had an energy of 320 times 10 to the 18 electron volts, which is, this muon had the amount of energy of dropping an apple from 50 meters.
Okay.
That's a lot of energy for a little tiny particle.
Right.
So they're extremely rare. Well, their detectors can't even detect that. I mean, it just, that's not even something that we would have to worry about. So 2 types of muon photography or tomography. I'm just going to probably say photography just because it's easier for me.
Okay.
But translate into the pedantic tomography if you like. It's absorption tomography, which involves dense things absorb things more than not dense things. I mean, that's like an X-ray right there. The other type is scattering, which if you've seen like crystals, X-ray scattering for determining the internal structure of crystals. That's for small things, and that's not what they're trying to do here.
So it's 2 kinds.
And we're using the absorption.
Okay.
Or the diaphane, which there's a link there. It goes to a website that talks a little bit more about that kind of detector, but that's the kind of detector that we're using.
I love that part when they give you links to dig in as far as you would like to.
So, as
how many
I mentioned,
rabbit holes do you want to go down?
Yeah, cosmic rays hit the atmosphere, produce a shower of particles.
That's a neat image.
Yeah, and that's artist rendering.
Artist rendering, right? Yeah, that makes sense. Particles are just too small to see.
And they don't produce visible tracks because if we'd constantly be seeing them. They don't just happen during the night.
We can see them if they go through like a bubble generator, right? Is that yeah.
So, muons,
we see the trail, I guess.
Muons decay 2.2 microseconds after their creation.
Okay.
But since they're going so fast, that translates their time is 46 microseconds.
Oh, right. Okay.
So that instead of going 660 meters, they're going the flavor that they're detecting 13.8 kilometers.
Yeah, that's what you mentioned earlier. Okay.
Yeah. So that's why they can use these.
Okay.
And it's also why we can't use them for looking at the internal structure of the Earth, but only for things that are sticking up out of the Earth.
Okay, because they can travel through it.
Right.
Okay, I'm with you.
And, you get a lot more muons coming from straight up, but of course that's not useful for them.
Mm.
Then
You
would
want them to go through the mountain.
Yeah. So the detectors are set for them through the mountain.
Okay.
And in here, they actually say that the detectors detect approximately 1 muon in a 1 centimeter square per minute.
Okay.
So this isn't a snapshot. This is, as you guys who do, astrophotography,
You leave the lens open, you capture a lot of light, and then you close it down. Yeah.
Yeah. They're doing long exposures.
Long exposure. That's a great way to talk about it. Yeah.
To have enough muons to actually show anything.
To generate that image.
Yeah.
Okay.
And basically what happens is muons of low energy don't make it through. Muons of higher than the energy that it would take to get through the object do.
Okay.
So, and they know that the expected distribution of muons. So if they're expecting to get 100 muons and they get 30, then they can use that to know what the energy of the lightest muon is.
Seems like you could figure out the density of that thing too, right?
Right.
Okay.
Of that one track through. That's why they use multiple detectors.
Okay.
They're doing a 3D, they're doing they can do a 3D image because they're measuring the tracks here. So a track that comes in this way, and then versus a track that goes this way.
Yeah, more okay.
But they're using multiple plates in here, so they can measure the track through the detector.
Ooh, Scott has a good question. When you're ready, go ahead.
Go ahead.
Oh, ready? Okay. So Scott says, I wonder if these muons could detect if a volcano was filling up with lava and is about to blow. That is an awesome thought. I love that.
Well, they have detected lava tubes, and I would guess that since magma, since it's still underground, it's magma. Since magma is higher density than air, then yes, they would be able to detect it. Now, can they tell the difference between magma and rock? I believe they mentioned that somewhere, that yes, they can.
Okay.
So I think that is possible.
Okay.
The other thing would be if they do this once a year or something, then they'd be able to detect differences in magma levels anyway.
Oh, yeah, that could be
differences. But so these are, consider that you can think of this as having a wide angle lens.
Okay.
So it takes muons, up and down, side to side. So it can image a fairly wide area.
Wow. Okay.
Because you can measure the track through the detector and know where that muon came from.
Right. That was the levels at the beginning that sort of, okay.
Yeah.
Yeah.
So from here to here, in fact, at the very top, they had the 3D plots. And we'll show that there. The 3D plots aren't extremely useful for what we're doing, but they're interesting. Yeah.
Well, to me, that's one of the things about doing these projects is you are actually getting a glimpse at what these scientists are working on, which I find just completely interesting.
Right. And if you've got 3 detectors, they're looking at this thing from multiple angles. And
so 3 of these cart things that have
from different angles pointing basically at the mountain. Oh, what's Daniel?
Well, why don't you finish?
Okay.
Anthony.
Hey, hi, Anthony.
Oh, hi, Anthony. You're fine. You're fine.
Is that tracks that pass through the same spot will have, so they'll know where the dense spots are 3-dimensionally in there. Through the long exposures, they'll be able to tell where the dense spots are. So,
all right, you ready?
Yep.
So Daniel says, I believe the smaller cat-sized particle events are called muons, and the cow-sized ones are called muons. There you go, Jeff. You started something. Yes, very interesting topic, Anthony. I actually love any particle physics stuff. Yeah. Oh my God, Daniel. Yeah. Because they're both on YouTube, so they can see the comments of each other. Yeah.
Yeah.
Cool. All right, you got more for us?
Yep. And this is the actual detector itself.
Right. So those 3 levels of
3 plates, and you can tell that you can see where as the particle comes in from different directions,
Yes.
you'd be able to tell by hit, hit, hit.
Yeah, and that's probably why they have the 3, so
Mhm.
you can get that.
Yep.
What's inside of those panels? Do you know?
They didn't say, although that link to the Delphine detector
Okay.
probably would go more into that.
And that's what this is, right?
Yeah.
That was at the top.
Yeah.
Of yeah.
And in fact, this image is probably from that link. And if you notice, these are numbered, but they are explained here. And
oh, cool.
There's actually a lead shield between the first 2 and the back one.
Oh, interesting.
Why? So that you know whether
the energy of the muon, maybe.
Well, yeah, but also, and it will absorb some energy, so you'd know whether the muon is going from the front to the back or the back to the front.
Oh, that's a great idea. Yeah, okay, I get it.
Also, there are other particles that can hit these, including electrons,
okay,
thing like hadrons, stuff like that. And the muons will go right through the lead. They'll lose some energy, but they'll go through the lead.
Right, okay.
Some of the smaller particles won't.
Oh.
And so they'll be stopped. You won't get it.
Boy, is this clever.
Yeah.
What a great detector.
And a hadron will actually scatter. So it'll hit the lead and produce a shotgun pattern on the back.
Oh, no kidding. Wow.
So we'll never see any of those.
Right, because we're focused on the muons, right?
Yeah, because the computer already pulled those out.
Got it.
In fact, they talk about there's 2 ways of making the detectors. One is to make it restrictive so that you're getting as few false positives as possible. Or you increase the computing power and compute out the false positives, which makes the detector more, better able to detect the muons. You get more data, more useful data, instead of less data, but all of it's useful. You get more data, you have to weed out a bunch of junk, and but you end up with more data.
Okay.
And computers basically chunk out a bunch of that, and they're using us to find the rest and train the computers.
Okay.
So that,
How do you feel about that?
Yeah.
But hey, it's a fun project. It sounds like I'm definitely going to go look into this some more because I love all this stuff. Okay, cool.
So yeah, these detectors are very prone to false positives, but they use computers to get rid of them.
Okay. You got some more there?
Yeah.
Right.
Lots more.
Here you go.
Like I said, when this group does something, they do it up. So they're talking about high energy cosmic muons from the side of the studied target. And basically, if it doesn't go through all 3 plates, also they know that it's not a real thing. It's not coming from the direction they're looking for.
Okay.
So it doesn't matter. And they're talking about hadrons, and here's where a hadron comes. It breaks up, sends stuff out here, and you notice this is a slow muon.
Okay.
And it hits the lead and just scatters. Another thing is that it can break up here and make a false line because it'll hit the different plates at different spots. And so that's one of the things that we're looking at too.
Oh, cool.
Although we're not detecting it as that, we're just detecting, it's not really a line.
Yeah, got it. Okay.
Another thing that can happen, and they talk about here, is that some particles can change direction. They hit an atom in the atmosphere or a molecule in the atmosphere and bounce. And things that are small enough to do that will change direction when they hit the lead. So you'll have line, 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 no line.
Okay.
Or they'll hit the ground behind the detector and come up through, which would look like a line coming from the source. Those are hard to filter out.
Oh, interesting. Okay.
But the computers can go like more energy. If it has more energy here than it does here.
That's the direction. Okay,
Yeah.
got it.
But it's not 100%. Because depending on how well they hit the each plate's detector,
Mm-hmm.
it'll lose more or less energy. So it's so background rejection. They're talking about how they try to get rid of the background noise.
Okay.
The task at hand, we just talked about that, and yeah, keep calm and find patterns.
Yes.
There's so many people looking at each image. Don't stress about whether you
Do
got
they
it right.
do they say how many? I know some of them it's like 15 or 20. Do they talk about?
If they said it, I missed it.
Oh, okay. Yeah. We got very short notice for this.
Yeah.
Ms. Denton told us Thursday morning.
And here's their team.
She was sick. Oh, hang on. Let me go back to the
Oh.
share screen. There you go.
Here's their team. He's looking like he came out of the military, but that's okay. She's looking like she's somewhere in the field. He's looking like he just woke up. Not a huge team.
Yeah, that's pretty decent size though.
Yeah.
That's cool.
Not like they don't have like 20 people up there.
All right. Yeah. Some of these are really big.
And the fact is FAQ is pretty good. What's a muon? Why do you need my help instead of using machines?
Nice. Awesome.
What if I do the task wrong?
Oh, yeah, do they say in there? Sometimes that's where you'll find the number of.
No, they just say.
I just find it interesting how how many they'll have.
What's my impact? What's the impact of my work on the science?
Oh, nice. I really like that part too.
Yeah. And they actually did a bunch here. In fact, this kind of detector found a hidden chamber in the Great Pyramid.
Oh, neat. All right, so Daniel comes in and says, Scott is correct. I found a December 2018 scientific paper where applied muography is aiding volcanology on the La Soufriere volcano of Guadalupe. I think they mentioned that one in this somewhere. I think I remember seeing that name.
Oh, possibly. I know that they said that they were looking at volcanoes and stuff like that.
Right. Yes.
Whereas, we look at density graphs, and these guys are good enough that they can picture it in their mind when they're looking at the density graphs.
Wow, really?
Yeah.
Okay.
Of course, we won't actually see the density graphs here because that's not what we're doing.
Okay.
That's.
You ready to go back onto
yeah.
the? Oh, he's looking at the field guide.
Now we'll look at the field guide.
Cool.
This is 3D plot interpretation.
Nice.
Again, this is mostly for just us seeing it because this isn't part of the actual. It only has a little bit to do with the actual task.
Okay.
But you can see kind of the track through the detectors.
Yeah, and I think understanding somewhat what's behind it really helps too.
Yep.
Plus, it's very interesting.
And they go into what's a pixel. I mean, some people might not know. But here's what happens is that you've got this plate here. It's got detectors going this way and this way. This particle hits kind of at an angle from the side, and so it hits this cell in this one and some other cell in this one on its way out. So that gives you, they'll be able to tell a little bit about its angle just from this.
So that's where the pixel comes in. It's a small unit of.
Right. And then it hits the second one and it does the same thing. And by lining them up, they've got pretty much as close to the exact angle as they can get.
Wow. Yeah. 3 points is a good way to triangulate things. And that looks like it's got 4.
Right. Yeah.
Nice.
Although 2 in each set are so close together that they're kind of make a very fuzzy plot point, but a very fuzzy direction.
Okay.
But by having multiple plates, they've got some separation there, so it basically gives them a better imaging. Okay, 1D plot interpretation. And they go more into that. And this is where you want to see the field guide and not go directly into it, which was my mistake when I looked at it the first time.
Yeah, because they have sort of a wizard going through to understand the.
And they don't explain all of this, and this is helpful. So this bottom is the voltages in each cell. Now, if something hits it, it increases the voltage in the cell.
Okay.
So these are where things hit
Mhm.
that one.
Okay.
Now this is only one plate. We're going to be dealing with multiple plates, so
Mhm.
so and they go into that. But that's the important thing right here is that the different voltages, because if you've got two hits, two different plates,
Mhm.
or you've got the same plate in two different directions,
Mhm.
they should have the same voltage.
Okay.
Introductory workflow. This is, again, they're talking about how these things flow through here. And this is what we'll be looking at here, is that we look for drawing a line in the gaps here.
Mhm.
And
Are they going to have the lines in there, or are you going to
in the
create
introductory,
them?
they have the lines, and then you determine whether
because
they're
the
right or not.
computer already
Right.
worked through those.
Yeah.
Okay, cool.
Yeah. And so that's the main thing. Also, some of them, like this one, has this spot and this one.
Mhm.
And this one, see, these voltages match, or no, they don't. But okay, I was wrong about that. Like I said, I basically didn't have a lot of time to look at this.
Yeah.
But since there's two dots here, it just means that one of them is a spurious hit.
Okay.
But so let's see, that's introductory workflow, FreeStyle workflow, same starting there. And we're given this, and our job is to draw the lines.
Okay.
And that's,
so if you do the introductory, you'll get sort of a feel for it, and you'll have an idea what the computers did and what you're looking for, and then you'll go into it and you'll do it.
Yeah, in fact, let me
go
to the tutorial.
Hang on, let me go back. All right, so you are in the...
Yeah, this is the tutorial here. You can see a little bit of the cast, but this is the tutorial.
Ah, got it. Okay.
So this is what we'll be seeing, and I've got my screen really zoomed in because it's it just shows they write really small in this, so I had to zoom in a lot so that you could read it through here.
Yeah. Cool.
So is there a pattern? Is the main thing there.
You know what we usually do too? I usually get a link for this
particular in fact, project. I'm in the wrong one. I'm not in the introductory. Let me go here.
Oh, there you go. Introductory.
Yep, there we go.
There's the lines. I was wondering.
Yep. So we'll go to the tutorial.
Very sorry, folks. I'm gonna go grab this link and put it into.
Yep.
Do I have it up? I forget. I will go do that. Go ahead, Jeff, and explain things.
So here they've got line and line, and these are two different. To get a 3D view of this thing, they've got two different lines there, but this is the same track.
Yeah, but there's scrolling. You got a scroll bar too.
Yeah.
So there's the third.
Yeah. So these are the three plates, but these are two views. This is a side view and a top view of the three plates. And the main thing that we're looking for is the line has to go through holes in the bottom because they're looking for places where the electron has, the voltage is higher. So it can't be zero voltage. So you're drawing a line between the spots of zero voltage. And this is just a fairly straightforward one. And that's, basically, are these the red lines you would draw? And that's for this one, it'd be a yes. Okay, so
you're kind of confirming. Okay.
Yep. Yeah. And this is the 3D view. And like I said, unless you're good at figuring out what you would see from this direction or in this direction, it didn't do me a lot of good. But
okay.
It might help some people.
All right, and there's that link, folks. Thanks for waiting. I usually have that prepped and ready to go before the show starts.
Now, here's one where, if it just grazes it, it still counts. But if it looks like it might go through one, then then you someone you would say no on the. So if she decides to click no instead, then it goes to this screen where you can redraw that line.
Oh, neat.
And
Okay.
see, there's two spots here that it could have come through. This one or this one. And if you go through this one, it misses that one completely.
Yeah.
And so.
But you said you didn't find any issues with
not
saw.
with the ones that I saw.
Yeah. Okay.
So, and again, here it's going through empty, kind of grazes, and then if you notice, it just hits right there.
Yeah.
So I didn't see any that were this close. So in this case, you click no because you wouldn't draw that line that way.
Yeah.
And so in this one, it's really hard to see through there. It's really hard to see in the tutorial too, unless you zoom in. But they redraw it so that it hits this gap here, and there you go.
Yeah, that's cool. So this is still, you could still do some useful things, and of course you're learning.
Right, yeah. So like in this one, it's like, yeah, you can move that easily enough one way or the other, but you know, you just pick one. You don't have to be right. You just have to be right.
Okay.
You know, because there's lots of people that will be looking at it.
Yeah, and of course, when there's discrepancies, those are the ones that they will decide, oh, we better take a closer look at these. And that helps them too. It helps sort through the different ones.
And like this one here, you can easily see that by moving it over this way, you can make that gap.
Yeah.
But again, you click no. And, you know, now here's one where, see how there's this one above here, this one above here. There's also this other pair here. Now, if they're paired, it's not a data glitch. Something hit the detector. And so you mark those so that it knows to get rid of those, because there should only be the pair that is above the zero, you know, the zero line for the gaps that you're hitting.
Okay.
Because of course, since you picked this one, it must be that voltage. You know, that must be the voltage. This is some other hit.
Got it.
But if you notice, it's not hitting any of the other plates, so it's coming in at a weird angle.
Yeah.
So that's, and you don't have to be precise. You just have to get in the general area. Although I will say that the bullseye is big enough that you won't have any trouble hitting the mark. It just has to be within the circle. You don't have to like get it exactly centered, because you know, unless there's two that are right next to each other, they're going to know which one it is.
Right.
You know, even their computer will be able to figure that out. Now, here's where, let's see, what things don't always work out. Sometimes there's no good path.
Okay.
In which case, when you go to redraw the lines and you don't find one, hit the back button and say, I don't see anything resembling a track. So give it a shot first. Don't like look at it and go, yeah, I don't see anything. Give it a shot. See if you can make a track. And then there, keep calm and find patterns. And then they're reinforced, because they like to advertise themselves. But hey, that's fine. They make good.
Yeah, they have good projects.
Okay, so here we go. This is a workflow. We're seeing gap. Oh, not quite.
Yeah.
This is the first time I've ever seen them not do it correctly in this workflow. Okay.
Got it.
Gap. No. Okay. So in this case, we actually get to draw lines. I never got to draw a line in this one. So when I hit the next one, I had to learn how to draw a line. But so we'll hit no here, hit next, and now track drawer. So what we do is we click on the gap here. You don't have to be exactly precise, except that I like to be. Oh, and you don't click, you click and hold. And you're making a line. And now let's see, this one or this one. Well, could generally be either, actually.
I think to the right of it is better for the
But remember,
second.
In the middle one, I'm pointing at the screen with my finger. I'm going to draw the line here. I think this one is the correct one because oops,
So
because
you
it crosses this line underneath that.
Ah, got it.
So, see, this is something that they don't tell you in the tutorial.
Oh, that's why the field guide is.
Yeah,
okay,
that's why I like the field guide. So then you go up here, look for
so just a little bit off.
Yeah. And if you notice, I'm trying to find the one where the middle one is underneath the particle up there. And it's not quite, but it's close enough that it might have hit the edge of that detector. So this is where I'm going with that one.
Cool.
Now, also, and if you notice, there are some spurious detections here and here, but they're nowhere near each other. So these are just glitches.
They're not. Yeah.
They're not paired, here and here.
Yeah. Nice.
So we're going to say done.
Okay.
And that's, and here, if you notice.
Those look like they're right on.
They're right on. And I did 10 of them, and this is all I saw. So you hit yes, that's how I would have done them.
Nice.
And again, if you notice, dead on.
Yep.
It just goes to figure after I told everyone I went through 10 and didn't detect any first. Okay. And see, there we go. Dead on, dead on, dead on.
That was a good chance to demonstrate what the possibilities are on here.
Okay.
Cool.
So now we'll go back here. Because if you just do the classify, I don't know which one you'll get.
Oh, I see.
So I always go back here and hit and go for this.
So, yeah.
And they have a more tutorial.
This is the FreeStyle one, right?
This is the FreeStyle. And they talk about, seeing what you see and then making the lines. So it's essentially the same thing that we were doing when we were fixing things, except that we don't have a reference line to start with. So they're talking about, creating lines like this and
that seems very doable, though.
Yeah, it's not, not really rocket science, and it's not totally tedious. You're only marking a couple things per plot, and
nice.
Yeah, and then here's this again. I don't find this useful at all, but you look through it, it might be useful for you. And so here we go. This is an example of extra. There's an extra pair in here, if you notice. In fact, this one is not over this track. This one is not over this track. So you would mark these two. This one you wouldn't mark because there's only one, and that's just some kind of glitch.
Okay.
So here's what they do. They mark these two because they're not over the the empty spot where your line went through. And and again, another example, and again, these and they're in roughly the same spot, but I don't know why they picked these and not others. This is the part, like I said, I didn't have very long to dig through this, so I don't know exactly why these and not these. It's just so more reading.
Yeah, so you definitely want to spend a little time figuring out what you're doing as well as doing the task. It looks like
they do say that marking the extras is not a task requirement. It's just as long as you're there, if you want to, it'll give them more data.
Oh, very cool.
What they really want are the tracks.
The lines. Okay.
They want the tracks. So Here's like lots of messy stuff.
Yeah. Wow.
And you can mark.
So yeah, if you go do this project, delve into why
Yep.
they've picked some of them and not others.
Yeah. So here is something that looks kind of messy. And you know what? Always hit yes, I can see a pattern unless there's no way a pattern could be. Like if there's nothing on one of the rows,
Mm-hmm.
always hit it because you can always hit the back button.
Oh, cool. Okay.
You see the back button?
Yeah, right there.
So if you
Good.
can't make a line, then hit the back button. So that's right. Okay, so
yep, click and hold.
Yeah, click and hold. So we can go through here. We can go through like, let's see, where is that? That particle's, that dot's about there, I think, in between those. And that could be one, or that goes through. Yep, that can't be one. Because it goes way off. So let's just pick the one that is most likely underneath that.
Yeah, because it has to go through all three, not just the first two.
And like I said, it wants to be underneath. It wants to be underneath one of these particles too. So there's one. I'm just going to give a shot on this one. It's probably the other set, but let's just see if we can.
Oh, well, but you can kind of experiment. Actually, you can play with it a little bit.
Take a look. That's one, but I'm going to erase that and just see if I can make one coming from this one too.
Yeah. Well, it looked like you can actually have them both on there, right? Or not? Yeah, no. I'm not sure that's one.
Yeah, I don't think I can make one through there. That basically, because if you notice here, even trying to hit this line here, it wouldn't be underneath this one.
Mm-hmm. So, well, it's nice that you can easily, remove them if it's not, if you don't sense that it's right.
Right. Yeah. So that's good because it's and it moved right as I
oh, you picked it up and moved it again. That's cool.
Yeah, because I want it to be underneath this one here when it hits.
Oh, right. Yeah.
Because that way they can tell which one of these it is on this row.
Mm-hmm. Okay.
And extra particles. Yeah, there are extra particles. Again, I really don't know how to pick these except that so I think I'm just gonna leave this one because I don't know enough to mark these.
Well, and if you delve into it some more, you can read that.
Right, yeah.
Figure it out.
Yeah. So I'm just gonna say done.
Very cool.
And that's it. Again, not rocket science except for the extra particles thing, which I didn't figure out in the time that I had.
Yeah, got it. Well, maybe we'll come back and look at it some more at some point.
Yep.
All right. Anything else you want to share there, Jeff?
No, that's
okay.
That's what I found. It's an interesting project.
Yeah.
And quite frankly, I have to get away from space stuff on Zooniverse because we ran out.
We covered them all already.
We've covered them all. Yeah.
So if you have any more comments for us, absolutely come on down, help us out.
Yep.
Answer your questions.
But I managed to find something related to space. And I think next time I'll cover the deep sea project too, because again, that uses muons.
Well, I was looking for the link and I saw some other muon ones. Oh, Scott has a comment.
Yeah.
Jeff did a great job with short notice.
Yeah. Thanks, Scott.
Very good. Very good.
Yeah. Shorter notice than I thought because my work lunch got taken up. So I was
you're going to do it at lunch today, right?
Yeah. So I did it tonight.
Yeah. Very good. All right. So get your free list of annual meteor showers. Visit meteorshower.com. I got a link here somewhere. There it is. And fill in the form, press the button, and get your chart today. Let's see, how do I do this? I do it that way.
Janie.
Oh, hi, Janie.
I like the phrase, keep calm and find patterns.
Yeah.
Yeah.
Thanks for joining us, Janie.
Yeah.
So some stellar events this week. We're talking about September 16th through the 23rd. On the 16th, that's actually tonight, probably in the morning, really, though. Mars and the Moon are in conjunction, and Neptune is at opposition. The 17th is the last quarter moon. And if you're local, and that's Thousand Oaks, California, or right in there, Los Angeles, the VCAS, Ventura County Astronomical Society, Star Party is going to be at Moore Park College again. And also, the next Globe at Night project begins. Oh, I got a banner for that one, too. There it is. So this is a 10-day project. It goes from September 17th to the 26th. If you are in the Southern Hemisphere, they want you to look for Sagittarius. If you're in the Northern Hemisphere, they want you to look for Cygnus. And what they want is to have people go out, take a picture of these particular targets and compare them to what they have on the charts on their site. September 22nd. A couple years ago, there was lights out for birds, and I've been trying to figure out what is that sort of a regular thing? Is it the same time every year? But apparently, birds, about 70% of the birds that migrate do it all in just 10% of the nights, and this is spring as well as fall. They go one way in at one point, and then they go back in the other point. Also, it's the September equinox. Spring begins in the Southern Hemisphere. Fall begins in the Northern Hemisphere. Do we have a comment?
Couple.
Awesome.
Cliff, having the same problem as not much happening in space lately. Oh, and you can actually see it. Are your skies clear now? And of course, when there's nothing out there.
Well, in the evening, we should have Saturn and Jupiter now, right, Cliff?
Yeah. But okay, and Daniel, does Zooniverse gamify participation or reward crypto or certificates for helping?
Not that I know of, but that's a great idea.
No, it's basically all for just doing it and enjoying helping with science.
Crowd solution.
Yeah.
For scientific projects out there. Yeah.
Now, if you log into the Zooniverse project, they do keep track of the number of classifications. I don't know that there's much tracking there, except that, like, I have however many hundreds of classifications that I've done for various projects.
Well, and I have heard that if you are some kind of significant part of a project, that you may actually be named in the project results, that kind of thing. Yeah. But I think you have to probably do quite a bit and, participate with them and get known, that kind of thing. But great way to enter into the scientific field. Well, did we have another one?
Well, also whenever you see the, members, tab on the about stuff, the project, the team.
Okay.
Along the right-hand side, they'll have a list of people, and that's probably where, if you're like a big contributor, you end up in that list.
Oh, okay.
And I'm not sure. That'd be my guess. They don't say.
I just remember reading it in at least one of them.
Yep.
That you may get named in a project for some kind of contribution. Yeah. Did you have another one? Yeah.
Okay. Daniel, again, it would be great if getting better governance policies could be treated like a citizen science project too.
Interesting idea. So we're back to, and my list of what I was naming, we're back to September 23rd. It's our Friday night show. And we're either going to have a guest or I will do another profile. Find us Fridays at 9 p.m. Pacific time on the Everyday Spacer Facebook page and the Everyday Spacer YouTube channel. Also, Mercury is in inferior conjunction. Jeff, you're up.
If it's ever in superior conjunction,
no, it's not going to be. Oh, hey, Cliff.
Yeah. Yep, okay. Saturn is pretty nice.
So it should be Jupiter that's really bright.
Well, yeah, but Saturn's up there too, so.
Yeah, and I'm not sure Southern Hemisphere might have a different. It might appear in a different relative position.
Stuff on the ecliptic, I think.
Yeah, they're on the ecliptic. But
yeah.
So you.
Okay. Other events and activities. Last month, our guest Joaquin mentioned several competitions for students. We found Society for Science which has a number of science and space related competitions.
Yeah, and I looked. I didn't see any significant dates because they're kind of in the middle of a cycle of the various ones. So
yep.
we'll keep watching for those.
Space Prize has a speaker series. Here's the YouTube link, and she's going to copy it into
Yeah, it's just a
chat.
YouTube link. It wouldn't be very interesting on the screen. So here comes. That should be clickable in the chat or on the YouTube.
Yep. And also Space Education Symposium. Oops. Talking about Saturn right above us. So.
Oh, okay. And I have a link for
a Space Education Symposium.
There it is.
November 12th, 2022, hosted by Human Space
Program. Yeah.
I just keep wanting to say the Human Space Program. Why can't
Frank White?
Why can't Frank afford a 3-letter word?
Especially for a writer. They used to get paid by the word, remember?
Yeah.
I don't know if that's still true, but
yeah. Space Apps Challenge. October. I'm trying to move my mouse over to your screen.
Okay.
It's not working.
No.
October 1st through 2nd, NASA has an annual event that's essentially a hackathon for space apps. So if you know what a hackathon is, you know what that is. Basically, you get together, form teams, and produce apps to.
Yeah, there's a little bit if you want to read it.
No,
okay.
That's essentially
we've done it a lot of the weeks before this.
Yeah.
And that one's not yet. We keep checking this nominated student with perseverance, and I think Lydia would be a great student. Our guest last week, but I keep looking. It still says it's coming in fall of 2022. So got a couple days.
Here. Yep.
Yeah. So if you or someone you know has done something interesting involving space exploration, science, astronomy like that, we'd love to share live. Join us again next Friday, September the 23rd. If Miss Denton can join us, we will have a guest. If not, I will delve into my third profile. I am going to talk about Ronald McNair, and I bet some of you actually know who that is. All right, you got anything?
No.
You got anything? Oh, I saw one
Daniel. $100 DIY Muon detectors are online.
No kidding. Did you do a search? That's amazing.
Mm-hmm.
Really, $100 for a Muon detector? Oh boy.
Oh, there you go. Buy 3 of them.
Scary.
Buy 3 of them, line them up, and you might be able to do some.
Triangulate the mountain or the volcano.
Yeah.
Yay. That is very cool. Shout out to Daniel, Cliff, Scott, Janie, Anthony. We really appreciate you coming and hanging out with us for Friday night. And folks, have a really great week. And we'll see you next week. Good night. Oh, where is it? Hold on. There it is.